Hello, my fine young Algebra 2 people. This is Mr. Hotard coming to you again. Today's lesson is going to be on sketching graphs of polynomial functions without using a graphing calculator. Now, you notice I said sketching graphs. I didn't say graphing. All right, graphing is when you're trying to get all the points as close to exactly right as you can. Sketching graphs is just using key features of the graph to make a general sketch, a basic shape of what that should look like. We're going to be using several things. We're going to be using the end behavior, which we learned about in the last lesson. We'll be reviewing that in this video. Also, something called relative extrema. All right, those are turning points on the graphs. The X and Y intercepts, and also something called multiplicity. So first of all, let's just quickly review end behavior from the last lesson. Remember, end behavior is what the graph's doing at the ends of the graph. And the end behavior is based on the degree of the polynomial, and it's also based on the leading coefficient. I'm just going to put LC. All right, remember, if that degree is even, if you have x squared, x to the fourth, and by the way, remember, what's degree mean? The biggest exponent. So if your biggest exponent is an even number and your leading coefficient, which is your front number of the problem, is a positive, do you remember what the ends of the graph look like? They should both be going up. All right, there might be some crazy stuff in the middle of that, but both ends of the graph are going to be going up. Now, if you have an even degree, even exponent, with a negative in the front, both ends of the graph are going to be doing what? Going down. Like in a parabola. Like if you have a negative x squared, both ends going down. All right, now if you have an odd exponent, an odd degree, with a positive in the front, that's like a positive slope. That graph's going to start at the bottom and end to the top. It's going to be going down on the left, up on the right. If you have an odd degree, odd exponent, and a negative leading coefficient, a negative in the front, it's doing the exact opposite. That graph is going to start at the top and end at the bottom. It's like a negative slope. All right, so you need to be familiar with those four patterns right there. All right, that's going to help you a lot when you're sketching these graphs. All right, and then also something we need to keep in mind, something called relative maximum and relative minimum. That's just turning points on the graph, where the graph turns around. All right, whatever the degree is, a polynomial of degree n, and what's degree mean again? The biggest exponent. Whatever the biggest exponent is in the problem, it can have at most n minus 1 turning points. All right, so if you have something that's x to the fourth, then it can have at most how many turning points? It could have at most 3. It could have less than that, but the most it could have is 3 turning points. All right, just however, whatever the degree is, 1 less than that, that's how many turning points it could have. Doesn't have to have that many, but up to those points. All right, one last thing called multiplicity. All right, which is just a fancy word. It's how many times you get an answer, or how many times you get a solution. Like when you factor a problem and then you get x equals blah blah blah, x equals blah blah blah. All right, most of the time you get in those answers just one time. All right, that would be a multiplicity of 1. All right, but sometimes you can get an answer more than once. Like back when we were solving quadratic equations, sometimes you got x equals 2, like you factored in x minus 2, so you got x equals 2 2 times. That would be an example of even multiplicity, when you're getting it an even number of times. If you're getting it more than once but an odd number of times, that would be odd multiplicity. So what happens at the graphs at these points? Again, most of the time you just get multiplicity of 1, so when that happens, the graph crosses through the x-axis at that point. Graph crosses through x-axis at that point. At whatever you get x equal to. All right, so an example of that would be like when we were graphing the parabolas. All right, you got x equals like -5 and x equals +2, something like that. All right, graph crosses through at those 2 points when you have multiplicity of 1, when you get each answer 1 time. Now, if you get an answer more than once and you're getting it an even number of times, that would be even multiplicity. The graph doesn't cross through at that point. What happens there, if you get an answer an even number of times, the graph bounces off the x-axis at that point. All right, so it doesn't actually cross through the x-axis, it just touches it and turn around, basically like a vertex or a relative maximum, relative minimum. So if you have like a graph like that, an example would be like if you got x equals 4 and you got that 2 times, it would just touch that point and wouldn't cross through, just touch it and turn around. All right, that would be an example of even multiplicity. And then odd multiplicity, if you get an answer an odd number of times but more than once, so if you get the same answer 3 times, 5 times, 7 times, then what happens is the graph flattens out. And crosses through the x-axis at that point. All right, so it's going to be similar to what happens with these, but what do I mean by flattening out? Instead of just going straight through, it would kind of like when we did x to the third, when we graphed that, how it kind of curved in, it would do something like this. It would come up, flatten out, cross through at that point, and then come back up. So right there, that would be an example of odd multiplicity, when you're getting this answer 3 times, 5 times, 7 times, an odd number of times. Okay, so that's a lot of information. Now let's try to synthesize this, put this all together to draw our graphs. So if you look at these 3 problems on bottom, all right, starting with y equals negative x squared minus 7x minus 10. Now this one, I already know how to graph x squared. We've been doing that. So you should already know what shape's that one going to be. It's going to be a parabola. And it's a negative in the front. What's that telling you about your graph? It's going to be open and down, because this is going to be even degree and a negative in the front. Both ends going to be going down. All right, so I'm going to leave a little bit of space. I'm going to have to do some work, but down here I'm just going to draw my graph. I know both ends going down. And also, if you remember this number in the back, do you remember what that tells you? That's the Y-intercept. So I know, I'm just going to graph, here's negative 10 down here. I know it's crossing through the y-axis at that point. All right, now, everything else, multiplicity and x-intercepts, I'm going to have to get those from factoring. And by the way, I know this can have, since it's degree 2, what's the most number of turning points it could have? It could have at most 1 turning point, 1 less than that. So now I'm going to have to factor this. I don't want a negative in the front, so let's just start by dividing out negative 1, just like GCF. So that's going to leave me x squared plus 7x plus 10. Now factor what's left. What numbers multiply to give me 10, add to give me 7? X plus 5, x plus 2. And so that means my answers, remember, you only get an answer from the GCF when there's an x there. So I get x equals negative 5, x equals negative 2. These are my x-intercepts. Here's negative 2, here's negative 5. All right, now, I'm not getting any of these answers more than once. I got each of these answers once. That's multiplicity of 1, so it's just crossing through at that point. It's going to look kind of like that, but crossing through. And I know both ends are going down. So it start down here, it would cross through the negative 5. At some point up here, I'm not sure where exactly, it will turn around and then come back down through the negative 2, keep going down, it's going to pass through negative 10. It's going to be a parabola looking like that. All right, if you want to know the vertex, you'd have to do negative b over 2a, but I'm not worried about that. All right, number 2. So I'm going to start by just sketching my graph down here, draw my xy axes. Let's just start with what we know. First of all, there is no number at the end. What's that tell me about the y-intercept? It's 0. There's no number without an x, so I know my y-intercept is going to be 0. So I'll go ahead and put a dot on 0, 0. I know it's crossing through there. All right, and then let's try to factor this. So this one, does it have a greatest common factor? They all have a what? An x. Factor out x. It'll leave me with x squared plus 6x plus 8. That's an x. And then I can factor this into x plus 4, x plus 2. But I also have this x GCF. So now this one, I'm going to get 3 answers. Remember, anytime you have x in your GCF, what's one of your answers? 0. I'm getting x equals 0, x equals negative 4, x equals negative 2. So I already have a dot on the 0. Here's negative 2. Here's negative 4. These are my x-intercepts. And I'm getting each answer once, so it's just going to cross through each of those points. Now, This is x to the third. If you go back to the original problem, is that even or odd degree? That's odd degree, and there's a positive 1 in front. So if I have odd degree with a positive in the front, my ends of the graph are going to look like that. It's going to start at the bottom, it's going to end at the top. So I know this graph's going to start down here, it's going to pass through -4, it's going to turn around at some point, pass through -2, turn around again, pass through 0, and end up at the top. Now, if there had been a negative in the front, it would have done the exact opposite. It would have started at the top, and then squiggled through, and then ended at the bottom. All right, one last problem. Number 3. All right, I'm seeing an odd exponent positive in the front, so the ends of the graph should be similar to this. This one should start at the bottom, end at the top, just like number 2. Okay, and then what's the y-intercept for this one? Y-intercept going to be 0 again. There is no number without an x on it. So let's draw our xy axis. I know I'm going to be passing through 0, 0. Now this one, when I factor out GCF, the GCF is not just x. They all have at least how many x's? At least 3. GCF is going to be x to the third. And remember, when you divide and you subtract the exponents. So x to the 5th divided by x to the 3rd, going to leave you what? X squared. And then that's going to be minus 6x plus 9. So I still have just that x to the 3rd GCF. And this is going to factor into what? Into x minus 3, x minus 3. So really, when it's the same thing twice, I can just say x minus 3 squared. All right, because it's x minus 3, x minus 3. And so now I'm going to get only 2 different answers. I'm going to get x in my GCF, so I know x equals 0. That's one answer. And I'm getting x equals 3. So I got 0 here. Here's 3 out here. Now, this time, these factors, they have exponents in it. This is where that multiplicity comes in. All right, because since this is x to the 3rd, this is like x times x times x. I'm not getting x equals 0 one time. I'm getting x equals 0 3 different times. That's odd multiplicity. All right, same. So this one's going to be, let me just say, this is like x equals 0 with a multiplicity of 3 because of that exponent. All right, and the same thing with this 3. I get x equals 3 how many times? 2 times. So this is x equals 3 with a multiplicity of 2. Just means I get that answer twice. All right, so since I'm getting, and I know it's going to start down here at the bottom, end at the top, because it's odd exponent. So I know, let me just draw the ends of the graph. I know the ends of the graph are going to look like that. All right. When it's odd multiplicity, what happens at the graph? It should flatten out, but still cross through. So I'm going to know it's going to come up here. It's going to kind of curve a little bit, flatten out, and pass through 0 and still go up here. But at some point, it has to do what? It has to turn around, head back toward the 3. Now, when I get to the 3, again, that's even multiplicity. What happens if it's even multiplicity? It bounces off the x-axis at that point. So it's going to come down, it's going to touch the 3, but it doesn't pass through it. It just touches it and turns around. So it looks a little strange, but you're used to strange things. You're in Hotard's math class. Okay, so now, next page. These are already factored for you. The hard part's done. You just had to draw the graph. So I want you to pause the video, try to do these 4. All right, let's see if you got them right. First one should be a parabola. You get x equals -2, x equals +2. Even exponent, positive in the front, so both ends going up, and a y-intercept's -4. All right, so that one's not too hard. Problem B, odd exponent, positive in the front, which means this graph's going to start at the bottom, end at the top. Y-intercept at -4 right here. It's going to touch the x-axis at -2, +2, and -1. I'm getting each answer just once, so it just crosses through. Problem C. I'm seeing an even exponent with a positive in the front, so both ends of the graph are going to be going up. This one's going to look kind of like a W. You got a y-intercept at +4, and I'm going to get x-intercepts at -2, +2, -1, +1. All right, so it's going to start at the top, and it's going to cross through each of those points. Cross through there, hit the y-intercept, cross through, cross through. Now D, this one was kind of weird. All right, D, I'm seeing an odd exponent, positive in the front. What's that mean for the ends of my graph? Starts at the bottom, ends at the top. All right, y-intercept is 0, so I know I'll have a dot right here. and then it factors into x plus 3 squared, so I get x equals 0, and I get x equals negative 3 with a multiplicity of 2. So 0, I'm just getting that one time. I know it's just crossing through that point, but I'm getting negative 3 2 times. Even multiplicity means it's going to bounce off of that point. It's going to start down here, touch the negative 3, turn around, and then cross through. All right, I know this is kind of confusing the first time you see it, but stick with it. Once you understand the rules, it's not too bad. I hope this was helpful. I'll see you guys later. Hotard out.